Hello, this is Hui. Welcome to watch my video, C++ Programming on Linux. In this short video, it will discuss another very important concept, proxy, talking about network and network applications. It's very often to hear the word proxy, especially in today's digital architectures. Proxy server or proxy service are played a very important role and widely used in many applications. There are many web pages and easy to find what is the proxy and how it works over internet. In short word, without using proxy, user make a request to the endpoint directly over network, and the destination server respond back directly to user side. Using proxy server or proxy service, user send a request to proxy server and the proxy server forward to the destination and the destination server respond back to the proxy server and the proxy server send back to the user end. In many applications, proxy concept is embedded as a proxy object and provide customized proxy service to help API improve security, filter against malware, log network traffic, analyze network usage, and redirect network traffic to improve load balance and network performance, especially for cloud or cluster-based architecture. There are many arguments discussed on proxy concept too. Look at the cyber man-in-the-middle attack flow. It uses same concept or flow as a proxy concept. So if a proxy concept has been used for good man, it's called a proxy. And if a bad man uses this, it will be called a man-in-the-middle attack. The example of this video, we are going to use basic TCP echo server created in previous video and adjust it to a proxy server. And then we use basic TCP client to test newly created proxy examples. Here on our Ubuntu Linux, there are two C++ programs created from previous video. Bev TCP echo server.cpp and basic TCP client.cpp. First, we compile them and test them. Now our program has been compiled and our executable basic TCP client and the Bev TCP echo servers. To test our Bev TCP echo server and the basic TCP client, we are going to use two terminals. On the top terminal, we are going to run TCP echo server. So the usage will be port number 1234. Bottom terminal, we are going to run basic TCP client. The usage will be 10.0.0.191. Port number is 1234. Now client make a connection request to the server and server accepted the connection. Now we test the message. Client input the message and the client send the message to the server and our server received the message. And our server received the message. This is we test message 1 and send back, and our client received this message. We send another message. Server received the message and the server reply back. Our client received the message too. Close our client. Our server received EOF and terminate connections. Back to our Linux, we're going to create a new program, Bev TCP proxy server.cpp, and we import from Bev TCP echo server.cpp, then adjust it to a proxy servers. R bev tcp equals server.cpp, and then we start adjust it to the proxy servers. For the echo server, we're listening one part and reply back to the same socket. For the proxy server, we have a listening on address. We also have to have a connect to address. So we copy these two lines, paste here, and we adjust this to connect to address. I start from our main function. Usage for echo server, we only need 2 arguments. For proxy, we need to add 1 more argument, connect to host and port numbers. First argument is listening on address, and the second argument will be connect to address. Also need a parse connect to address. We copy 6 line yanked, paste here, replace from listening address to connect to address. 132, 137, S, connect to address from argument 2. Parse field. Next, there's no change. Create a new event base, create a listener, and we set the accept error callback, and we print information on screen. Dispatch base, and at the end, free our listener and free our base allocated memories. Now we finish adjust main function. We're going to start adjust accept callback functions. Here is accept callback functions. For the echo server, we only have 1 buffer event corresponding to 1 socket. For the proxy, we have 2 buffer event listening on socket and connect to socket. So listening on socket, be in, buffer event in, create another buffer event, be out, copy these 2 lines, paste here. Be out will be the client connect destination servers. So the FD will be -1. If we create a buffer event, be in and be out, run, and we will be quit our program. For the buffer be out, we have to make a connection to connect to address. If a connection failed, print out the error message. Free the memory allocated for be in and be out and quit. After that, we just set up a callback for echo server. Read callback, write back to the same buffer event, but a proxy read from buffer in and write to be out. So pass be out as the parameter for the read callback and the event callback. When we received from be out, and we will be write message back to the be in, which is the client side. And both be in and be out will be the enable, read, and write. Now we finish adjust accept CB. We're going to adjust event CB callback functions. Here is our event callback function. For proxy server or service, since there are 2 buffer events corresponding to listening on socket and connect to socket. So when the EOF event or error event happen, it will synchronize between 2 buffer events. So we make a adjust for these 2 events. First, we need a parse argument. We name this partner. if event EOF or event error happened, before we free the buffer event of listening on, we have to make sure all the data have been write to the connect to buffer event. Or we have to finish write responder data back to the client side before we close the buffer event. Oh. Flush or pending date. If partner buffer event has date remaining, we have to flush the date from the other side. So we set end writing callback. Read callback. Now end write callback, event callback, parameter. Now and disable reading from other side. Else free the BEV. Now we have to create a new callback function, ending writing callback. Copy these two lines. Finish this typing error. For ending writing CB, first we have to create EV buffer from the buffer event output. If length of EV buffer is equal 0, if there's no more data remaining in this buffer event, then we can close this buffer event. Next, we are going to adjust our read callback. Here is our read callback. First, we need to parse the argument to get the other side buffer event. We name it partner. Source will be from the BEV input buffer event copied to our local buffer, receive buffer, and then we just print out message received. If there's no other side buffer event, we're going to cleaning the source buffer and return back. For proxy server destination buffer event will be get from the partners. Then we move source to the dest, which is from the listening on to connect to, or from connect to listening on socket. Now we finish adjust our read callback and we finish our proxy server program. So now we save our program. We compile our program, echo server, proxy server, and the basic client. Now our program has been compiled and our executable be basic TCP client, BEV TCP echo server, and the BEV TCP proxy server. To test our example, we are going to use 3 terminals for 3 executable. On the top terminal left, we are going to running TCP echo server, port number 4567. Our echo server starting listening on the port number 4567. On the top right terminal, we are going to running proxy server, started listening, port number 1234, and connect to echo server, port number 4567. proxy server, starting listening port number 1234, and forward connect to the port number 4567. Bottom terminal, we're going to running our basic TCP client. Connect to the port number 1234. Port number 1234, proxy server. So you can see our client made a connect request to the proxy server, port number 1234, and the proxy server accepted and make a forward connect request to our echo server, port number 4567, and our echo server accepted, and then we start send message. Client, we input a message, test message 1, and client send a message to proxy, test message 1, proxy server received the message, test message 1, and send to our echo server on port number 4567, and the echo server received the message and send back. So our proxy server received the message again. This time is received from the echo server and reply back to client. Our client received message 1. We send a second message. Our proxy server received the message 2, sent to the echo server reply back to the proxy server, and the proxy server send back to the client. When client send EOF, proxy received EOF sent to the echo server close the connection, and our proxy not receive message, so we just quit client. Hello, this is Hui. Thanks for watching my video. Wish it's helpful and useful. It's going to be great to have your feedback.